Tanisha, you can start now.
Okay, I'm audible.
Yes, you're audible.
Okay. The secret of getting right is getting started. I, Tanisha, the host of today's webinar. Hello, everyone, and good evening to all of you. I welcome you all in today's session. Hope you all are doing great. On behalf of Wholesame's family, I welcome you all on today's international webinar on the topic Basics of Machine Learning. And our guest of honor and today's speaker is Kavya Shri AN. We are really pleased by your presence, ma'am. Machine learning is a study of computer algorithms that let computer programs to automatically improve through the experience without human intervention. Or we can say machine learning is the extraction of patterns out of data. Machine learning is a branch of artificial intelligence that focuses on data analysis and the development of computer programs. The sole purpose of machine learning is to make computers able to learn automatically. Before I proceed, let me take a brief moment for the introduction of my organization. SEMS Welfare Foundation, it is a not-for-profit organization. It promotes healthy lives, balance and active communities, strong business. They work in the areas of education, social welfare, women empowerment, skill development, and entrepreneurship, livelihood generation, employability, health, and more. Our today's speaker is Kavya Shri AN. Kavya Shri AN from third year pursuing Bachelor's of Computer Science with specialization in machine learning and artificial intelligence at MEPCO Select Engineering College, Shivkashi. She is a restless learner and curious in learning by updating herself with new technologies. At present, she is the Google Developer Student Lead, Microsoft Student Ambassador, and a part of AWS User Group India. She has handled a lots of webinars, technical events, and contributed as a guest speaker in various communities. So, before going further, I request all the participants to remain mute throughout the webinar. If any doubt occurs, you can type it in the chat box or you can raise your hand. Now, I would like to give my heartiest welcome to our guest speaker, Kavya Shri AM. Over to you, ma'am.
Yes, ma'am. Thank you for the brief introduction, Tanisha. And let me proceed. Shall I share my screen now?
Yes, you can.
Am I perfectly audible first?
Yes, ma'am, you are audible.
Yes, thank you. I'll just share my screen. Hope my screen is visible.
Yes, ma'am.
Yes, thank you. So, myself, Kavya Shri, and she gave a very brief introduction about me. And I thank the SEMS organization for inviting me as a guest speaker for this session. And thank you everyone who are present in the meet. And today our topic is machine learning. Nothing but we are going to see the brief introduction. It's just an introductory part for the beginners. I'll say what is machine learning and what are its types, and we'll have a hands-on session in one application, which is nothing but the prediction application. So let me proceed. So first of all, let's see what is artificial intelligence, machine learning, and deep learning, because all these three terms seems confusing for the beginners. So first of all, artificial intelligence is the simulation of human intelligence processed by machines. So that's nothing but giving the human intelligence to machines. That's what is nothing but the artificial intelligence. Whereas machine learning is it gives a computer the ability to learn without being explicitly programmed. In a normal programming, we'll be just explicitly coding all the programs. But in machine learning, the computer itself learn the like it learns from the patterns and from some sort of algorithms the thing which is very insightful. So that's what is nothing but the machine learning. So next, coming to this is the overview of the AI, machine learning, and deep learning. And from this picture, it depicts that AI is a big circle, and machine learning is a subset of AI, whereas the deep learning is the subset of machine learning. Deep learning process all the images and the image recognition, face recognition, all sort of applications come under the deep learning. Whereas the prediction like stock market prediction, house prediction, The prediction using the classification and the regression all comes under the machine learning. And these two, machine learning and deep learning, are the subset of the artificial intelligence. So now let me proceed next. So that's what I have explained. Deep learning is concerned with the neural network, and because we are just feeding the images and we are just training the images and we are predicting from the images, and that's what is nothing but the deep learning. Machine learning is we are just providing the data. The data set is provided to the computer, and the data which is provided is trained, and further it is tested for getting the better accuracy. That is what is nothing but the machine learning. So now coming to how machine learning works. As I have said already, we are just giving the data as the input and we are just training the data. We are just using there are actually n number of algorithms, and we are using a particular algorithm, and we are just testing the data. And if the data which we are testing gives a better accuracy, we are using that algorithm to deploy the model. So now we have trained and tested our data from the data set. After we are satisfied with the accuracy, we are just getting the new data which is not already known by the computer. So if that data matches and if it gives the better accuracy, the model can be deployed. This is how the machine learning works, and this is the overview of machine learning and it's working. And now coming back to the types of machine learning. Machine learning is broadly classified into the supervised learning, unsupervised learning, and reinforcement learning. The key words in supervised learning is that we are using the labeled data set. In unsupervised learning, we are using the unlabeled data set. In reinforcement learning, you can remember it as the best example for reinforcement learning is the robot, because we are training the robot and it just walks or does some sort of actions by the experience. So the experience sort of learning comes under the reinforcement learning. The labeled data set, those kind of learnings come under the supervised, and whereas the unlabeled data set learning comes under the unsupervised learning. So now let us see about the supervised learning. So supervised learning, as I've already mentioned, it is nothing but learning from the labeled data set. The output will always be a classification, like it may be a discrete output, either yes or no, or it may be some sort of numerical value, whereas in terms of regression. So supervised learning, we are using the labeled data set, and it functions as the input-output pairs, because obviously we are just feeding the data and the output will be either a discrete or it will be continuous. Discrete in terms of classification, whereas continuous in terms of regression. So this is how you can better understand the concept of supervised learning. Here you can see the images of the apples and mangoes, and these are the data which we are feeding to the model. And after the model gets trained, when an unknown image is given, from the training it has already taken, it will be predicting correctly that the unknown images is apple. So that's what is nothing but the supervised learning. So the key takeaway here is that in supervised learning, the machine learning algorithm learns from the labeled data. So as I've already said now, supervised learning is divided into two broad categories, which is nothing but the classification as well as the regression. In classification, it will be a discrete output, either yes or no, or true or false, apples or mangoes. And in regression, it will be continuous output in terms
Excuse
of
me, ma'am.
yes, ma'am.
Sorry to interrupt, but I guess the slide is not changing.
Is it
It's
changing now?
it's still the first slide.
Oh, really? I'll check it again.
Yeah, it's changed. Type of supervised learning.
Is it changed now?
Yes, ma'am. It's, I guess, ninth slide. Type of supervised learning.
Yes, ma'am. Is it changing
Yes.
now? I'm changing.
Yes, ma'am.
Is it switching now correctly?
It's still on the ninth slide.
Now is it in 10th?
No, ma'am.
Okay, fine. Then I have
You have
my
to go back
sliders.
and
Is
then
this
switch
visible?
the slide. Now it has changed.
Okay, fine. Then I'll present in this similar way. I think there are some issues in sharing, so I just have in this way.
Okay.
So I hope this is visible well now. So in supervised learning, there are two broad categories, which is nothing but the classification as well as the regression. In classification, we'll be getting the discrete value as the output, that is either true or false. And in regression, we'll be getting a real valued output in terms of stock market prediction or house price prediction. Those are the examples which fall under the category of regression. Now I'm changing my slide. Is my slide changing? Can anyone tell me, please?
No, ma'am.
Okay, fine. Then I just have this way. And there are a lot of algorithms which fall under the classification category, which is nothing but the decision tree classification, random forest, and k nearest neighbor. And in regression, there are models like logistic, polynomial, and support vector machines. I'll try to share my screen again. I'll try again. Once again. Again, I'll try once again. Sorry for the interruption. I'll share my entire screen. Now let me check it out. Is it changing now?
Yes, ma'am.
Yes, ma'am.
Okay, fine. Sorry for the inconvenience. And these are the algorithms which comes under the classification, which is nothing but the decision tree classification, random forest classification, and k nearest neighbor. And under regression, there are actually a lot of algorithms, but now I'm just giving you a glimpse of the very important or the famous algorithms which are used for the prediction models. And under regression, we are using the logistic regression. Logistic in the sense it is the discrete valued output, and polynomial regression as well as the support vector machines. So under classification, now let us see the scenario of rain. Our intention is to find whether it will be raining or not. So this kind of problems comes under the classification example. So we are giving the data set. The data set which we are giving, for example, it consists of the humidity and pressure, which is nothing but the input, and the output is whether it will rain or not. That is the output. It is discrete. That is, it is either rain or not rain. So it comes under the classification. Now I'm changing my slide. Can anyone tell me, please, whether it is changing?
Yes, ma'am.
Okay, thank you. And this is a sample data set which we are feeding. And from this data set, the computer learns itself. That is, this data set has the columns of date, humidity, pressure. The humidity, pressure, or the input. And the last column, rain, is the target which we want to predict. That's the output. So this is the data set which we are going to train our computer. So the data set was mentioned in the tabular format, and in this we are just mentioning in the form of functions. It is a different representation of the data. That's nothing new here. We are just giving the function of humidity and pressure, and the output is given as the equal to. It's just the different representation, nothing new. So the data set which we already mentioned, it is represented well in the form of graphical representation. Here the blue spots here denote the rainy day, and the red spots denote the non-rainy day. And the x-axis is the humidity, whereas the y-axis is the pressure. So if I ask you a question of what is the classification, whether this white spot, that is a new data point, whether it will be red or blue. So if I ask this question, most of you might have answered it must be red because it is nearest to the red. And that's correct, because it is really it's very close to the red data point. So it falls under the non-rainy day category. And here comes the algorithm under classification, which is nothing but the nearest neighbor classification. this white data point is spotted based on its distance from the nearest data point. So here, as the nearest one is red, it must be obviously red. So it must be a non-rainy day. And now if we ask you a question, what must be the whether this new data point, that which is white in color, whether it should be either red or blue, you might be probably guessing like it must be red. But in this case, it should be blue because you have to consider the amount. There are a lot of blue points, but there is only one red point. So here comes the next classification algorithm, which is nothing but the k nearest neighbor classification. Here, if you see, there are a lot of blue points and only one red point. So obviously, this white data point must be the blue data point, which is nothing but it must be a rainy day. So under this condition of humidity and pressure, the white data point must be a rainy day, which is nothing but blue. So the conclusion is the white data point must be the blue data point. So this is what the technical definition. The nearest neighbor, we are just seeing the class of the nearest data point, and for the k nearest neighbor, we are just seeing the most common class out of the k nearest neighbors. That is, we are just considering a broader picture and we are not just only seeing the nearest data point. So that's the difference between the nearest as well as the k nearest. And now coming back to the drawback of the k nearest neighbor classification, it needs a lot of computation because we have to calculate a lot of distances and we have to, so it takes a lot of time, and that's what is the drawback which comes under the k nearest neighbor classification. And this is what the decision boundary which comes under the perceptron learning. So the decision boundary here splits the data points of red and blue in a proper way so that when a new data point is fed, it would be classified properly. So we have to note that always the decision boundary must split the data points equally. It must be either the straight line, but not always it will be a straight line. So to overcome that, there comes the support vector machines. So as I have already told you now, the drawbacks of the perceptron learning is that always the data points will not be separated properly by a straight line. So to overcome that, we'll be using the support vector machines. So the result of the perceptron learning rule is it will be either 0 or 1. 0 in the sense of soft threshold and 1 in the sense of hard threshold. And we are unable to express the uncertainty. So in classification, we couldn't just judge the probability of its occurrence. We are just able to know the extremes. That is, either it will occur or not, or it will be either 0 or 1. But we will not be able to understand or to know the probability of its occurrence. I hope my slide is changing now without any trouble. Is it so?
Yes, ma'am, carry on.
Okay, thank you. So this is the other pictorial representation of the soft threshold, and which also depicts the same information. That is, it will be either showing us 0 or 1. That is, the extreme values will be noted in the classification, and the probability, those kind of things cannot be inferred from that. So to overcome this, we are using the support vector machines. The support vector machine's intention is it just use the maximum margin separator, so to get the better accuracy of the unknown data point. So in this picture, you could see that there are red data points and blue points, and the decision boundary here in the left picture, that is in the left graph, it is not so properly located because it is nearer to some of the red spots here and the blue spots here. But it is far away from some red and some blue, so it's not a proper way of aligning that decision boundary. And if you see the right side graph, the decision boundary is very close to the red spots alone, but it is away from the blue points. So it is also a not proper way of aligning the maximum margin separator, which is nothing but the decision boundary. The decision boundary must always be at the proper distance equally from the both the data points, that is both the sets of classification, to give the better accuracy for the new data point which is fed to the system. So in this picture, it depicts that the decision boundary is equally located from both the both the sets of data points. So when a new data point is fed, it would give the proper output. That is, the output's accuracy will be great enough, and that's what the key takeaway from the maximum margin separator. And as I've already told you, the decision boundary can't always be the straight line always. So for different scenarios, we can use different dimensions of decision boundary. Here it is of more than 2 dimensions, as it is represented as a circle here. And now we have seen about the classification, which is nothing but it gives a discrete output, either rain or not rain. In the case of regression, it gives a real valued output, which is nothing but the continuous. So the example here, which I have given in my slide, is regarding the stock market prediction, which is nothing but related to money. So the output will not be yes or no, or true or false, or rain or no rain. It will be a real value. So that's what is nothing but the regression. So this is how the graph of regression looks, and the advertising and sales are represented here, and the data, that is the regression line, by some sort of mathematical calculations, it is represented here. So now we have seen about the supervised learning, which is nothing but feeding the labeled data. That is, we are feeding the data which is labeled. We are just telling the computer that these are the set of apples and these are the set of mangoes. But we are not just giving the pictures alone without labels. In case of unsupervised learning, we'll be just giving the data without any labels. So that's what is the main takeaway of the unsupervised learning. So in unsupervised learning, only the input data is present, and the artificial intelligence learn the patterns in these data. So as we are giving the unlabeled data set, it's a role of machine learning to learn the patterns from those kind of data and to infer from those kind of input data. And it will just come to a conclusion. And when the new data is given, it will draw the output with a better accuracy. So the example of unsupervised learning is that it is used in the genetics purpose, for example, the clustering DNA patterns and to analyze evolutionary biology, and is also used in customer segmentation, or understanding different customer groups around which to build marketing. So in some sort of marketing strategies, as well as in biology field, this kind of unsupervised learning methodology is used. So this is the main example, which you'll be clear when you see this. So here the input data is some set of apples and mangoes. Here the apples and mangoes are not labeled. We are just giving the unlabeled data set to the model, and from some what to say, like some analysis or some pattern recognition, the machine learning model, it would just train them from the data set, and it will come to a conclusion that when we just feed a new data, it will recognize that these are the set of apples and these are the set of mangoes by some sort of statistical analysis or pictorial statistics. So from those way, the unsupervised learning works. The main thing is it is using the unlabeled data. So as we have seen in supervised learning, it is classified as either classification or regression. And in a similar way, in the unsupervised learning, it is classified as either the clustering or association. Clustering is the similar groups, group data points, or the similar group items are clustered in a similar pattern. So that's what is clustering. And association is nothing but the relationship between the data points is taken into account. So let's see a brief about clustering. Clustering is an unsupervised learning task that takes the input data and organizes into groups such that similar objects end up in the same group. So when they are just applying in the field of biology and in the genetics research, when the similar genes or nearer, and they just form some sort of groups, and that's what is nothing but the clustering. And K means clustering is that it takes into account many data points in the available cluster space. So this from this graph you could see there are 3 clusters, which is blue color, red as well as green, and the diamond shape is nothing but the cluster center for those specific clusters. And as there are 3 clusters, there are 3 cluster centers available. So initially we are just feeding the unlabeled data. Unlabeled data in the sense it's a plain thing. So this is the data which we are feeding. You can remember this is the analogy. So these points or the data, you just think it of like that, and we are just giving the unlabeled data, because you could see that there's nothing similarity. Everything is white in color. So we are just giving the data as such to the system, and it's a role of the computer to some sort of pattern analysis. It should just divide these points into some sort of clusters based on this distance. It may be either Euclidean distance, and there are a lot of mathematical algorithms running behind it, and we don't know what's running behind the hood, but from the front end point of view, we could just get the output with better accuracy. That's what we could feel well. And this is what the data which we are giving. And we have to choose the number of cluster centers, because the number of clusters formed will depend on the number of cluster centers. And it's up to the programmer to choose how many cluster centers he wants. In this case, we can just take 3 cluster centers, which is nothing but red, green, and blue. So there must be obviously 3 clusters, that is 3 clusters of groups of points with similar patterns. So based on the distance, it just get grouped among themselves, and finally we'll be getting 3 clusters. So if there is a new data which is given, it will probably allocate that new data point to either of these 3 clusters. So that's the main takeaway of the unsupervised learning. So finally we'll be getting the output as this. These are the 3 sort of groups of clusters. So now we have seen about the supervised learning and unsupervised learning. Now let's see about the reinforcement learning. Reinforcement learning is another approach to machine learning, where after each and every action, the agent is nothing but the doer. That is, you can take it as the robot in this case, gets feedback in the form of either reward or punishment. Reward in the sense you can map it out with a positive value, and punishment you can just take it as the negative value. So this is what the overview. The environment is the place where you can think it as the environment is a place where the robot walks, and the state is the change of the occurrence of the position. And if it does the correct job, it will be getting a reward, and if it does the wrong job, it will be getting the punishment as the negative number. So if it gets the negative number, it will be aware that it shouldn't get the negative number. So it will just learn from the experience. So that learning from the experience is nothing but the reinforcement learning. So the Markov decision process, it comes under the reinforcement learning. There's a big story behind it, but now I'm just giving you an overview of what is what. I'm not just telling in depth about any specific algorithm. I'm just telling the overview. So this is how the Markov decision process can be viewed. There is some set of states and some set of actions, and the transition model. Transition model in the sense from one particular state to the another state. The intermediate model is nothing but the transition model. And finally we'll be getting the reward function for the state which it goes. So this is a good example of the reinforcement learning. You can think it of this yellow point as the robot, and these red squares are the hurdles, that is nothing but the barriers, and this green is the target. So first the yellow point, it moves to the right. Arbitrarily it moves to the right, and when it moves to the right, it gets hit because it's a barrier. So when the next time it just moves, it will not be just turning to right, because it knows that it already has visited, and it might have got the negative value. So it is learning from the experience, and next it will be moving through upwards, because it shouldn't move right, because it learned from the experience. So it moves upward, and finally just exploring the whole maze. That is, finally it will explore all these squares and learn from that experience, and finally it will reach the target, which is nothing but it is learning from the experience. That's a key point to note here. So it is the reinforcement learning. So the agent will start exploring the space, learning which state action pair it must avoid. That is, from the experience, it will learn what must be avoided and what must be done further. So the algorithm can be probabilistic, that is, choosing to take different actions in different states based on some probability that's being increased or decreased. That is, whenever it do some state, it will be getting either reward or punishment. If it gets reward, it will just take into account that the path can be followed, and if it gets punishment, it will neglect the path in the future movement. So when the agent reaches a green square, it will get a positive reward, learning that it is a favorable path to take the action. And when it just repeats the next similar way, it would probably follow that particular path, because it might have learned from the experience. So that's nothing but the reinforcement learning. And now let's see a hands-on session. Hope my screen is visible now.
Yes, ma'am.
Okay. I hope you might know about this Google Colab. This is the environment where we'll be using these cells, and we'll be just giving the text in the markdown cells, and we'll be doing the prediction sort of things, and we'll be training the models, and we'll be feeding the data set. All those kind of steps can be done in this environment. And this is the console of the Google Colab, and here you could see a file folder. Now what we are going to do is that we are going to do a prediction project. That's nothing but the mini activity. Could think it like that. That we are going to predict whether it will be raining or not. So for that we must need a data set, because the main thing is the data set. We must have a data set. We must train the particular data set, and we must be fitting the data set in a particular model. That is, we must train the model then, and we must test the model, and finally we can test the model with the new data. So that's what is the main point to note here, and that's what we are going to do now. So initially this is a file folder. I'm just taking the data set from Kaggle, and you have to download the data set. I'll just show you how to take the data set. You have to go to Kaggle website. Now I'm going to take the rain prediction data set. So I just search it as, I just search rain data set. It's named as weather of Australia. The data set name is. So you'll be getting the link as follows, which is mentioned now. So you have to go to that website. For taking the data sets, this is the particular website, which is nothing but Kaggle is very useful. And here there are a lot of data sets which is already available. So you have to surf the data set which particularly suits your project, and you have to just download it. I have downloaded already. I'm just telling the steps what must be followed, we have to download the data set, and it will be downloaded in the local. So after downloading the data set from this particular website, we have to go back to the Google Colab console, and we have to upload the data set. Upload in the sense you have to click this up arrow and that icon. So here you have to go to the particular path where you save that data set, and you have to upload it. I have already uploaded in my case, and if you have not uploaded, you couldn't run the project and you couldn't load the data set. The initial step is to load the data set. Without loading the data set, nothing further steps can't be proceeded. So the initial step is to load the data set. So just download it from the website, and you have to give the correct path, and you have to upload it in the console first. And initially we need some import statements to proceed, which is nothing but pandas. Pandas is for doing some statistics, and numpy is for numerical Python, and matplotlib is for visualization purpose, and seaborn is also for visualization purpose. And I'm just setting dark background for my convenience. And as I've already uploaded the data set, I have to load that data set. So for loading the data set, I should give the command as pd.readcsv. Always we couldn't use the big word as pandas. So we are just using as pd. So the pd is a short convention which will be following, which will be using further in the codings. So we are using the read CSV function, and inside that function, we are just copying and pasting the path of it. So after opening this, you have to just click over that, and there comes a pop-up menu. And from this pop-up menu, you have to choose copy path, and you have to copy the path and you have to paste it over this parenthesis. So in the read CSV function, we have to specify the path of the particular data set. So after specifying the path, we have to get the overview of how the data set looks. That is, we have to get the overview of what are the columns and what are the rows which is available. So to have the brief overview of how the data set looks, that is how many columns it possesses. So to know that, we are using the head function. So the head function is to get the overview of the data set, like to know how many columns are present. So by running this cell, after specifying all the commands, that is the codings, we have to run each and every cell. I have already typed, so I'm just running and showing now. So after loading the data set, we have to run it. And after running the head function, you could see as there are a lot of columns here. From this, you could infer that 23 columns are present in this data set. So to have the overview of how the data set looks, we are using the head function. Now if I just give an error, and if I run this, you'll be getting the cross mark. That is nothing but it shows the error. So just know the functions before you proceed. And once you run the cell, the green tick mark shows that you are going in a proper way and it's right. The coding which you are given is right. And now we have seen the overview of how the data set looks. And next, now we have to describe how the data set looks. Describe in the sense the statistical analysis, like the minimum temperature, maximum temperature, and the humidity at 9 a.m. and humidity at 3 a.m. and all those kind of things that is nothing but related to some statistics. So those kind of things can be viewed under the describe function. So from df.shape, from shape function, what we are doing is that after we are running, we'll be getting the output as the number of rows and the number of columns located. Initially, for every data set, if the amount of data is large, then the output will be giving a better accuracy. So our intention is to feed the computer with a big data set. That is, it must have a lot of data. So the output accuracy, when we are just feeding the new data, it will be probably high. So after running this df.shape, we are getting us 1,45,460 rows are present. That is a humongous amount of data, and 23 columns are present. So at once we are just loading and we are doing these kind of things to know about the data. After that, we have to pre-process the data. Pre-process in the sense some values may be null. Those values must be removed. So that is what is nothing but the data pre-processing. So to infer what are the columns which has lot of null values, we are using the info function. So from the info function, actually the number of rows is 1,45,460, but in the you could see as in the cloud 9 a.m. there are only 89,572 columns are filled. The rest of the columns are blank. So it consists lot of null values. So those kind of columns can be neglected because it does not contribute a lot, and it has a lot of empty blocks, empty cells available. So we have to drop those kind of columns. Already we had 23 columns. Now we are dropping uh, evaporations, sunshine, cloud 9 a.m., 3 p.m. because it consists least amount of data. As initially we should have 1,45,000, but by using the info function, we could understand that it just consists only of 89,000. So there are a lot of null values present. So we have to drop those columns. After dropping those columns, we have to get the overview of how the data looks. That is whether those kind of columns are dropped. We must check it out. So we are using the head function again. And now if you see, you couldn't find this sunshine column, evaporation column because it is dropped out as by using this drop function which we have done here. So we have done the data pre-processing, and dropping the drop NA is nothing but dropping the null values. Axis 0 represents the x-axis, and after doing all such pre-processing, when we are using the shape function, we are getting only 17 columns. At first we had 23 columns, but now we eliminated 5 columns. So now we are having only 17 columns, and the rows is 1,12,925. So to get the name of the columns, you can use the df dot columns. And after pre-processing, you have to use the label encoder to change all the strings present in the data set to the integer values, because the computer can learn only from the mathematical zeros or ones. It couldn't understand the characters. So you can see here, wind direction 9 a.m. It shows the strings, that is nothing but western, northwest, southeast, all sort of strings must be changed to the numerical values. So for that we are using the label encoder, and we are just fitting each and every column and we are changing it, and that's what is given here. And after using the label encoder and after changing, now if you see wind direction, everything is changed into the numerical value. So we have done every pre-processing steps are completed. So now we could see here, the last column is the target column. This is the target which we have to predict. So we have to drop that particular column. Axis 1 represents the y-axis. The y-axis, in the sense, we are just dropping the drain today. And as we have used matplotlib library and seaborn library, they are used for visualization purpose. So by this figure function and scatter plot function, we are just viewing the graph and to have the overlook of how the data looks. This is what the scatter plot. Here humidity is the x-axis, and time and temperature is the y-axis, and the purple spots here represent the 0. That is, it is not raining. But if the humidity increases, obviously the probability of rain increases. So when it reaches to 80, there are a lot of orange spots, which denotes the probability of rain, which is nothing but 1. So this is a heat map. It is also a different way of representation. All these are used for visualization purpose. It doesn't contribute to training or testing the data. So after pre-processing and visualizing how the data look and comparing and contrasting the specific features, we have to split the data. And for splitting the data, we are using the train test split function from the model sklearn.model selection. And For testing, we are using only the 10% of the data, and the remaining 90% of the data used for training. And to get the important metrics for the to getting to check out the accuracy, we are using the classification report, confusion matrix, as well as the accuracy score from the sklearn dot metrics. So these classification report and confusion matrix are used to check the accuracy of the final output. So for those things, we are using the these kind of metrics. And the model which we are going to train this data set is a logistic regression. Logistic regression is that it gives only the two output, either yes or no. Here in our sense, whether it will rain or not rain. 0 for not rain, 1 for rain. And we have to first create an object of it. Logistic regression must be imported from the learner model, sorry, linear model. And we have to use the logistic regression function, and we have to create the object of LR, and we have to fit the model. And after that, we have to predict the model. When you run this code, you will be getting the accuracy score, confusion matrix, and classification report. So by seeing this, you could infer that in the logistic regression, the accuracy here given is 82%, which is not so good, but okay. Sorry, 85%. You must see here. That's the macro average. The accuracy is 85%, which is mentioned here. And now let's try it out with different algorithm, which is nothing but the decision tree. So we have to import the decision tree classifier, and we have to create the object of it, which is nothing but DT. And we have to fit the model, we have to predict it, we have to use the metrics, that is nothing but for checking the accuracy, we have to use accuracy score and confusion matrix. All of these are the uh, performance metrics for the machine learning algorithms. So from by using these performance metrics, we could see how well or how better the accuracy is given. That can be tested. So for decision tree, by running this cell, you could infer that the accuracy is only 79%. But in the logistic regression, we got 85%. In decision tree, we are getting only 79%. And we are just trying out another algorithm to see whether we are getting better accuracy. If it gives the better accuracy, then we'll be just we can feed new data which the computer have not already seen. So it will probably give the best output, that is the correct output. So now let's do with random forest classifier, and we have to import the random forest classifier from the sklearn.ensemble, and we have to create the object of it, that is RF, and we have to fit the model, we have to predict it, and the parameters for fitting is X train, Y train, and for predicting it is the parameter is X test. And finally we have to pass this Y test and the predictions, which is nothing but the resultant of these things, to the performance metrics to get the final accuracy. And if you check it out for random forest classifier, the accuracy is 86%. It's relatively good compared to the decision tree and the logistic regression, which we have tested earlier, because it is of 85% and another is something around 79%, I think. Yeah, obviously correct. And let's check it out with another classifier, which is nothing but XGBoost. This also gives the better accuracy of 86%. So from this, we could infer that XGBoost classifier as well as the random forest classifier, these models gives the better output. That is, it gives the best accuracy. And so when so these from these four algorithms, that is nothing but decision tree, logistic regression, and XGBoost as well as random forest classifier. The XGBoost classifier as well as the random forest classifier gives the better accuracy for when tested with the data. So another new data which the computer has not already seen can be fed, and the output can be checked. If checked, it will give the proper and correct output. And that's what is the conclusion of this rain prediction project. And that's it for today's session. Hope I think this very useful for you, and I truly trust that this is very useful for the beginners who try to learn the machine learning from scratch and try to explore more. And I like to thank SEMS organization for giving me this wonderful opportunity, and thank you.
Thank you so much, ma'am, for this wonderful webinar. The session was very informative. Now, I would like all the participants to drop your questions in the chat box. Pooja, you are not audible.
Am I audible now? Hello, am I audible? Hello.
Yes, Pooja, you're audible.
Ma'am, my question is, what skills are needed to be involved in algorithm search?
I couldn't get you. Can you repeat it again?
Ma'am, what skills are needed to be involved in algorithm search?
Algorithm search. In what specific way are you asking? Can you
Uh,
elaborate it well?
for a person who is just starting up with this algorithm, so what are the basic skills that need to be kept in mind while studying this?
Yes, as far as beginners are concerned, you have to learn everything from scratch, no? So you have to have a clear idea. There are a lot of n number of resources nowadays available in the internet because now everyone are just surfing over the internet, over the YouTube for learning. So there are a lot of tutorials which are very useful, and there are a lot of courses. So they are explaining in a very great manner. And I don't suggest anything specifically. Just explore, just Google it, and you'll be getting everything in a fraction of seconds. Everything is in your hand. You have to optimize your time, and you have to spend a lot of time. If you have really good interest, you will just come to know more about it, and just Google it and see a lot of tutorials. There are a lot of tutorials which they are explaining in a very better manner with proper examples. So go ahead. Thank you.
Okay, ma'am. Thank you. Ma'am, the next question is, can you brief about the difference between automation, machine learning, and deep learning?
I couldn't hear you well.
Ma'am, I'm asking the difference between automation, machine learning, and deep learning.
Oh, okay, fine. Machine learning is nothing but now I have explained a project, no, that is rain prediction. All these kind of predictions comes under that is by the manual data set, that is nothing but the text data set. All these comes under the machine learning. Whereas in the deep learning, if you see, we are just feeding the data. Now in machine learning, we are feeding the data. In deep learning, we will be feeding the images as the input. So in deep learning, it is concerned only about the images. And automation, under automation, both these machine learning as well as the deep learning falls, because in both these kind of things we are just feeding the data, and when a new data is given, the output is predicted. So both is automation in this case. So deep learning as well as machine learning comes under the automation, whereas in deep learning it is concerned more about the images data set.
Okay, ma'am. Thank you. I guess
Kapriya,
are there.
am I audible?
Yes, you're audible.
Okay. Kapriya, in the final statement, you showed that with the help of machine learning and applied with the forest classifier, yeah, the prediction was 81% something that. Okay.
Yes,
So
yes.
here my point of view is that what is the limitation of this random forest classifier?
First of all, it's a good question. There are no best algorithms. It depends on the data set. For a particular data set, some algorithm may give better accuracy, and for another data set, another algorithm may give the better accuracy. So it's like a trail and error out pattern. You have to check it out, and there's no definite like benchmark that this is the best and if this algorithm gives this particular percentage of accuracy, this algorithm is best. Nothing is like that. And it is a comparative study of the accuracy. That's it.
No, question was that what are the basic limitations? Why sometimes we are not going to use the random forest classifiers? What is the disadvantage?
That's what random forest classifier is nothing but when it actually depends on the data set first. For linear logistic regression, the data set must be in such a way, and in this particular machine learning basics session, I have not told everything elaborate. And if you want to know more about it, just Google it. There are a lot of things to know. And in this 1 hour, I just gave you an overview, and I couldn't convey a lot. And if if the opportunity is given, I'll be just elaborating in the further sessions.
The main limitation of this forest classifier is that because there is a number of trees which
Yes,
makes the
obviously.
algorithm too slow. That is a disadvantage, and it is not suitable for a real-time application also.
Yes. Actually, the elaborate form of decision tree is the random forest classifier. In random forest classifier, there are a lot of decision trees involved. Whereas in decision tree, only one specific decision tree is involved. So obviously, when compared to the normal decision tree, the output of the random forest classifier will be obviously great. And in most situations, it will give the better accuracy because it's a cluster of decision trees.
In this classifier, can we describe the relationship between the data?
I couldn't get you what you're saying.
My question is that in this classifier, can we describe the relation within the data?
Relation within the data, I just don't know much about it. But now I have only concentrated on training the model with a particular algorithm and to test the performance metrics and to choose which one is better.
Whatever the data you have taken, that is Australian main data. In that data, can you describe the relationship within the data?
For visualization purpose, you could infer from those kind of heat maps and scatter plots. You could see the visualization, the interrelationship among the features.
No, that is the main disadvantage of this classifier because we cannot describe the relationship within the data. We can't describe. That is the biggest disadvantage of this classifier. But somehow we are just taking, but not always we are taking. We will not take this type of classifier. That's why different thing.
Okay, cool. I just said in my point of view, and if you want to know more about it, or if you want to convey something, please convey in the chat box because we are running out of time.
Okay, it's all right.
Thank you.
Okay, ma'am. Thank you so much for clearing the doubt. So over to you.
Ma'am, I would like to ask one question, ma'am. What way is this useful in research studies, ma'am? Research.
Ma'am, in research field nowadays, everything like in PhD projects too, everyone are nowadays concentrating on the prediction projects. That is nothing but the brain prediction, tumor prediction, and those kind of things. That is predicting nowadays when we face corona, those kind of statistics are taken, and we are predicting the corona whether it will be just rising in future. So from the data set which we already got, so in those kind of aspects in research field, it is useful.
Thank you, ma'am.
Thank you, ma'am.
Okay, thank you, ma'am. I guess no more questions are there. Okay, then over to Tanisha. We can move forward with this.
Thank you so much, ma'am, for answering all the questions. Now I request everyone to please switch on their camera so that I can take a screenshot.
Done.
It's done. Thank you, ma'am, and thank you everyone for joining us today.
Thank you, ma'am. Thank you, everyone. Have a nice day.
Thank you.
Thank you, ma'am. Thank you.
लड़की अच्छी लग रही है।